Hello there and welcome to the series of videos going through the content of A-level maths. Here we're looking at resultant moments, so we can answer questions from exercise 4b. So this is going to be effectively including now more than one force on a beam, on a balancing beam. It's the result of more than one moment. So an important formula we have to remember here is that a moment is calculated by doing force times perpendicular distance, and in this diagram here all of the forces are being applied in a perpendicular direction, so that's great. It's quite an easy question in that case. What we're asked to work out here is to calculate the sum of the moments acting around pivot P. Now we're going to have some clockwise moments, some anti-clockwise moments. If the value of those anti-clockwise moments and clockwise moments perfectly balance out, we'll have a zero resultant moment, but it's probably more likely the case that there are going to be more of one type of moment than another type of moment, and we'll have to do a one subtract the other. So a good idea for this type of question here is to think about all the moments from this pivot point P here. Now the first moment, that's this one up here, is going to be calculated by a force of 5 times a distance of 3, and if we imagine a clock around this point here and it's going upwards on the left hand side, that's going in the clockwise direction, so that's 5 times 3 is 15 and it's in the clockwise direction. For the second force now, it's a calculation of 4 times 1, but this is going down on the left hand side of the clock, so that's going to be going in an anti-clockwise direction. And for force 3, this is a calculation of 1 times 3, and this is going to be going upwards on the right hand side of the clock, which is equal to an anti-clockwise direction. So our answer here is 3 Newton meters in an anti-clockwise direction. So the resultant moment of this particular diagram of forces here is that we clearly have more clockwise moments than anti-clockwise moments, 15 against 7. So the answer here is going to be 15 minus 4 minus 3 gives us 8 Newton meters in the clockwise direction. So that is the answer for what is the resultant moment for the forces on this diagram. Okay, another type of question here where we have effectively two bits of string that are attached to two separate forces, one trying to pull it anti-clockwise, one trying to pull it clockwise, and it's affixed to a pin that's attached to a pin board here. So we've got two forces. Let's work out both of their moments, see which one's bigger, and then do one subtract the other one. So for force number 1, we've got a distance here of 2, a force here of 5, so that's going to be a total moment of 10. And if we imagine the clock, it's going to be going in the right-hand direction on the top of the clock, which is in the clockwise direction. For the second force here, we're going to have a calculation of 4 times 5, which is 20, and on the left-hand side of the clock, it's going to be going in the downward direction. So in that case there, it's going to be going in the anti-clockwise direction. So in this case here, we have more moments going in the anti-clockwise than the clockwise direction. So the calculation here for the resultant moment is going to be 20 Newton meters minus 10 Newton meters equals 10 Newton meters in the anti-clockwise direction. Okay then, your turn to have a go at these questions here then. Very similar to the ones we've done before. Make sure you identify that you're taking a moment from point P. Okay, pause the video and try this question out. Right, okay then, let's get started on this question here. So we've got a handy clock over here just to help us out with knowing which direction is going to be clockwise and which force is going to be going in the anti-clockwise direction. So let's get started labelling up our forces. We're going to have 1 here, 2 here, and 3 here. So for moment on the force number 1, it's going to be a calculation of 3 times 4, which is 12 Newton meters, and if we put the clock at the center point of P, we can clearly see here it's going down in the on the left hand side of the clock, which would be going in the anti-clockwise direction. So this is going to be anti-clockwise. Force number 2 is going to be this one here. It's going to be a calculation of 1 times 3. So that's 3 Newton meters. And if we bring back that clock, it's going to be going upwards on the left-hand side of the clock, which will take it in an anti-clockwise direction. So we're taking it in a clockwise direction, rather. And for force number 3, it's going to be a calculation of 1 times 2, which is 2 Newton meters. And bringing back that clock, it's going to be going in the upward direction on the right-hand side of the clock, which would take it in the anti-clockwise direction. So we can clearly see here we've got 14 Newton meters going anti-clockwise, 3 Newton meters going clockwise. So our total moment here, or resultant moment, is going to be 11 Newton meters in the anti-clockwise direction. Okay, great. The next question is from this pivot point here then. So the forces that are further away will have greater moments, or greater multiplier on the moments, and the forces closer will have a less multiplier because they're much closer to the centre of the clock. Okay, so let's label up our forces then. We've got force 1, force 2, force 3 and force 4. So working out the moments for force number 1, it's got a calculation of 1 times 4, 4 being the distance away from the pivot point, 1 being the force, so it's going to be 4 Newton meters. And we're also going to need to know which direction it's going in. It's going downward on the left hand side of the clock, so that's going to be in the anti-clockwise direction. For force number 2, we're going to have a distance here of 3 times a force of 2, so that's going to be 6 Newton meters. And this is going to be going upward on the left hand side of the clock, so that's going to be taking it in the clockwise direction. For force number 3, we're going to have a calculation here of 2 times 3, which is 6 Newton meters. And that's going upward on the left hand side of the clock as well, so that's going to be going in the clockwise direction. And for the last force here, it's going to be a calculation of 1 times 4, which is going to be 4 Newton meters, and that's going in the anti-clockwise direction. So we can see here now we've got 12 Newton meters going in the clockwise direction, 8 Newton meters going in the anti-clockwise direction. So it's going to be 12 minus 8 equals 4 Newton meters in the clockwise direction. So there we are, excellent. That's the answer to this question here then. So have a go at plenty of the other questions from page 75 of exercise 4b, particularly those exam type questions and those problem solving type questions as well. Great, thanks very much for watching.